screen space. Hello and welcome to this stream. My name is Will, and we're going to be doing something quite exciting today. I'm just going to do a little bit of housekeeping, so do bear with me. Just going to quickly share my link. And that should be that. I didn't even know if it came up. Just going to quickly double check that. No, I didn't. 1 second, guys. Gonna just edit my post. Just to share this so people can find. Not sure what's going on with the URL, so that will have to wait. Okay, guys, hello and welcome to the stream. My name is Will. This is CSharp walkthroughs. So today, as the title suggests, I want to go through something rather exciting for me. Coming from a video game background, I've always been into the notion of developing video games as an actual thing that will happen. You know, when you come as a gamer, you start to think about the idea of how do games work. How is this character on the screen doing what the character is doing? So in this particular video, what I want to do is utilize the tools offered by C#, Visual Studio, and kind of from the ground up, just craft a game. Now, for this particular walkthrough, in this part, in my previous live streams, I've sort of targeted around that 1 hour, maybe 1 hour and a bit mark. I'm going to try and keep it as concise to about 1 hour, keep it somewhat practical. So we're not going to be able to do everything in the scope of what I may like to do. So what I've done ahead of time, I kind of scaffolded a bit of code already that I want us to kind of go through. I'm just going to zoom in a little bit. Just to kind of give me a head start so that we don't really waste time with all the kind of setting up things and like the initial structure for the render flow. I've kind of done the majority of it already, or like 50% of it at least, just so we can kind of hit the ground, you know, good stride. And then I'm just going to check my OBS session real quick. Yeah, I think it's fine. I'm hoping it's fine because I'm not dual screening. It's really hard to know what's going on the screen without like interrupting the stream, and I don't want to distract people. So I'm gonna trust that everything's fine. The level should be okay. And yeah, if I was a little bit more prepared, I'd be able to check the chat at the same time, but I might not be able to do that without distracting the stream. Let's get straight into this. So, what we're gonna have for today? Okay, so here's the thing. I was thinking to myself, what kind of game would I like to design? What kind of game do I like? And this is kind of a educational, walkthrough, but I kind of want to make it something that I would like to play. Do excuse me. So I thought fighting game, because I used to play a lot of fighting games, maybe RPG. I want to make something really quick in terms of a proof of concept, and I don't really mind puzzle games. I've always like, Zelda has puzzle elements, even simple games like Super Mario, right? There's always puzzle elements, so you can't really get away from that. So in my aims, I know at the top I have here, build an extremely simple LAN sockets functionality to send and receive packets. Yes, this is probably going to be a little bit later down the line. What I want to focus on today is actually part 2, draft a simple high score based puzzle game demo. Okay? And this might be split into like a couple or so streams because of time. I'm going to really try and nail this to around an hour or so, but nothing more than like an hour, 10 minutes or something like that. And then what I might actually touch on today is implementing local networking. So this kind of touches on sockets thing. Networking functionality for the game to enable rudimentary local multiplayer. So what I actually did ahead of time is I was exploring some of the options provided by this namespace. Where's it gone? System.net, which gives me access to the sockets class, which is over here. And what's fascinating is that I actually managed to create a little bit of flow. You know what? I will leave the sockets demo till the end because it's nowhere near finished. But if I'm not mistaken, there are packets being sent. I'll just quickly show you guys my solution explorer so you can see my folder structure. So I have my model, views, and controllers folders. So I'm trying to implement a little flavor, should I say. I'm not saying a one-to-one, should I say, a one-to-one structure of, design patterns that I know I'm not using great English, but I'm not trying to follow the MVC pattern on a one-to-one basis, but I'm trying to kind of borrow ideas from MVC and sort of bring that into this game development, just so it's easier for me to maintain the code, write the code, test it, and extend it if needed, you know? So I kind of loosely separated my logic into model, view, and controllers. I also have a networking class, so I'll just show you guys what's going on. Also, if anything like disconnects, because my computer's not the best, my connection is not the best, I'll be up and running in no time. I'm in a communal space. Happy Christmas, by the way, guys. Happy Christmas. Anyone who's, just enjoying the festivities, happy holidays. I'm in my family home, so if anything, I will just pause the stream. If I need to go off screen, I'll be back. Anyway, back to this stream. So I have my networking class. I have NetSocket. And I have a few things here. I'll just kind of gloss over it in a very high level. Maybe towards the end, I will kind of go into what the logic is doing. What I wanted to do is just kind of implement this client-server sort of a network structure. And if I go to, say, server, basically what this does is that it, make sure I've got the right terminology. I have this kind of structure whereby I don't have particular logic in this class, but what it does, it calls from the NetSocket conn class to do a couple things: bind, listen, and accept network requests via sockets. And then the implementation of this logic actually lies in this NetSocket conn class. So if we just kind of go into the class itself, I have a few lines of code. I'm attempting to initialize a socket. I get the local IP address of the machine. I accept any incoming requests. And then I have a packet handler functionality to create a packet, a byte array, which is effectively a packet so that you can send messages over the socket. And this is very fun. I mean, like, it's sort of a new frontier for me to go into, like, the networking sockets standard and things, but it's one I'm really embracing because it's so much you can do. If you ask me, a little bit of an anecdote, I think web is next, right? Web is probably going to be the next step. Whatever the next step in tech or video gaming is, the web won't be too far behind that. So anyway, that's just a little bit of an anecdote. And so I have that there. And if you know what, I'm going to just quickly go to my clients class. So, and then we're going to get started on actual game design. So here, and I do hope to use this at the end. It'll probably be a different session, a different workshop though. Yeah, same kind of idea here. So I have this client class, which calls a functionality called connect. And then connect, the implementation is in a class called NetSocket, what's it called? NetSocket conn client. This is actually the implementation of the logic. I've got connect, I get the local IP address of the machine, i.e. the client. Then I call begin connect from my socket object. And then if connect, then I send a little debug string, or I construct a little debug string there. And I create a data packet. And this data packet was eventually, this is what I got up to. So it's very rudimentary, but what I'm trying to do is just monitor the packet itself. And what I want to do, if I can successfully send, say, a very simple hello world message over this very, very, very simple network, basically, it just means that I could potentially have LAN play on the cards. Speaking of cards, this game, I did kind of name it Battle Cards. You can probably see it up here, hopefully if you can read that. Now, the idea is I want to make a card game because there's not too much to do in the way of animation and creating assets, But then I just decided on making this kind of, as I said in the description, this kind of Chu-Chu-Rocket. It's an old Dreamcast game. It's a puzzle game where you control these units of mice and you have to get them into the home rockets. Now, the thing is, I did actually make a proof of concept for this kind of game. I wanted to show it here, but I'm on a machine that doesn't have footage of the game, I think, in my file explorer. But I might be able to put a link to it somewhere if I can find an old video or something on my channel. But I did make a little proof of concept, but I want to really improve it because, it needs a lot of work. If you've seen it, if you happen to know what I'm talking about, if you've seen some of my older videos. So with that all out of the way, you know what, guys? Let's jump straight into this. So I'm just gonna collapse this view. I'm gonna go to my main page CS file, and let's see let's do this. Let's follow the notes so we have a bit of structure. So we're gonna do this first. Draft a simple high score base game. What we're gonna do in this pertaining to this aim. So we're gonna go. We're not gonna cover sockets in any great amount of depth today. We're gonna go down to where am I? Mechanics and tooling. As I said here, we're gonna do a Chu-Chu-Rocket style game. Game mechanics should be simple. That's something I really want to get to. So what we're gonna first do, build a simple. Let me just zoom in a little bit more. I think that'll help. We're gonna build a simple render pass system to draw graphics. So if you've seen any of my videos, and let me just quickly check my dashboard. Just to make sure everything's okay. Yeah, that's calm. Just make sure I'm up and running, and I just leave it on like here. Sorry about that, guys. So if you've seen my previous videos, you know that I'm quite partial to the Win2D runtime. It's a small library that allows you to develop or program fast, smooth 2D graphics. I'm sorry, excuse me. I'll get a sip of my coffee there. I'm just joking. Okay, so basically, the Win2D library sort of leverages DirectX functionality, if I'm not mistaken. It sort of sits above the DirectX API layer in order to access its functionality. And in essence, I believe, if I'm not mistaken, offers some kind of abstraction in that sense, in that you're basically writing C# logic, but you are accessing underlying Direct 2D functionality to power the graphics, the Win2D runtime. We're going to be using that. And I've already kind of scaffolded what I want to achieve on a fundamental level with this game. So obviously in the constructor, I've gone ahead and created on the XAML animated canvas. There are three main components, or three main members you have to kind of get started if you want to use Win2D, and that's the create resources event, which pertains of course to a method that will basically generate the resources, the bitmap graphics for your game, for your program. The draw call is handled by this draw event, and the update calls is handled by the update event. We're going to go through this briskly, go through the scaffolding, then we're going to kind of build on it and see what we can start. If we can just get like a simple scene. So today we're going to try and get a bit of a graphic on the screen. We're going to hopefully get input parsing working. I don't know if I've put that yet. Input parsing. Tooling, maybe I'll do that in another stream if I deem it necessary. I don't think I have the I need to do a bit more due diligence as to what kind of useful profiling tools I might need. Otherwise, I will just kind of do a straight on approach and just rely on debugging and things, simple debugging, and of course, kind of borrowing from MVC pattern and other good standards is always a plus. Where am I? So let's focus on the render pass. What's happening so far? I'll take you quickly to the main page.xaml. Now, what you're going to see here is it's a strange scene. So I have here my main view box, and in my main view box, I have some XAML components, I have some XAML controls. Now, the idea is that I wanted to kind of have the main gameplay in the middle of the screen while you have some HUD, excuse me, while you have some HUD controls on the side, so you can kind of like control what you're doing, not only with your keyboard and, you know, like keyboard input, as I'm going to aim to use, but also perhaps like using the HUD on screen. So I'm just kind of experimenting with that, seeing where that's going to go. Remember, this was meant to be a card game, so that's why I was thinking along the lines of more like an RPG kind of thing. We'll see how that goes, what works best. And the animated canvas is here in the middle, if I'm not mistaken. And yeah, so that's the animated canvas. And what we're going to do, so the render flow is as thus so far. The program actually constructs and then create resources. The create resources event is called. What I've done, excuse me, is that I'm hooking this event, the load resources, to this where am I? It's hard to see. Generate resources, which is a function that I have in a class called load. Oh wait, sorry, let me just make sure I got this right. This load animated resources. What is this? Okay, so load animated resources is a class in my view folder. Oops. Oh, I'll just go back. So remember, I have my view, which basically pertains to handling all the logic regarding the user interface. I have the model, which is all like the business logic. Like, so I've got my draw update calls here. And I've got a controllers class, which kind of handles user input and interaction. But so from the user interface, kind of bringing that logic to the application for processing. So that's kind of how I'm sort of structuring this. I don't have an underlying framework. I'm just basically using it as more of a folder structure, data flow / access in a conceptual level. So what we can do, I'll take you to this class in my view. And so far, the idea is that I am basically making a list of lists, a canvas bitmap list. So this might get a bit confusing, but do bear with me. So I have a canvas bitmap list, which is basically a canvas bitmap object. If you're familiar with in 2D, you know what that is. So it just allows you to basically construct bitmap objects from image files. There's many overloads in order to construct this, but the way I'm doing it is using image files stored at a local directory. And I have a list of lists. So I have a list of canvas bitmap, okay? And I have a file path list. So I have, again, a list of lists, file paths. It's going to make sense why I'm doing it that way. Let's go straight to the load bitmap file path functionality. I have a for loop. So what this does, it adds the needed file paths for the assets to be subsequently loaded to the render flow. So what I'm doing here is that I am looping through the count of sprite sheets. So if we have, say, a sprite sheet, we went on our image editor, we created a sprite sheet. There's two approaches. I can either make the tile map approach. I'll just go to my notes section here. The optimal way, should I say, approach one, is like tile mapping, whereby I have, say, let's just say, for an example, this is an image file, image.png, right? And in this image file, what we might have, I know this is really rudimentary for like a graphical illustration of what I'm trying to do, but do bear with me. So if we have an image file, we could say this is, I don't know, sprite1. Oops, spelled sprite wrong. We could have image file sprite1. And then for our sprite sheet, let's just say we have a 4-frame animation, right? And we are basically conveying our animation as PNG files. That's sprite 1, 2, 3, and 4. Okay. And then what I can simply do is pass these sprites to the render flow. So I could say I can have my for loop, and then I can say counts. So let's just say for the count of, I'm just going to use pseudocode, count of files, and that's in the wrong place. So for the count of files, which is actually 4, so we have 1, 2, 3, 4, we're going to do some looping. And so what I'm going to do here is I could say, I don't know, let's say list of index. So if we have like image list holding the images by the file path, access by index. For each of these, we want to add basically the file path, right? something like that. So we're basically adding the file path to our list so that we can subsequently say construct something like bitmap object, and we're passing, the idea is that we're passing our image list via index, right? And then as a result, we kind of get this bitmap object, okay? That's the idea. So we're trying to get this bitmap object from a stored PNG file. That's the first approach. That's the approach I will be using generally. Now, it's not the best or the optimal approach because it takes up a lot of memory. When you think about it, you have, let's say you have high quality assets, even when you compress them, you might have assets in the range, PNG storing RGBA values. It could be anywhere but to a few kilobytes to quite a few megabytes, considerably speaking, depending on, limitations of your hardware, your development hardware, your target machines, what kind of spec you want your game to ultimately sort of lie in the window of. You're going to be very conscious of how much resources you're expending here. You're going to be very conscious as a games designer / developer. So what a lot of people do, and this is not actually that tile mapping approach, this is just like, should I say, let's say frame by frame approach. I'm making that up. But the more kind of standard way is this kind of tile map approach. And it's very interesting. It's a very efficient method. I have written functionality for this in another application. Maybe we'll look into optimizing what we're doing here in a subsequent stream. But we have this image. Let's just call it sprite1 for now. Let's just call it sprite sheet 1. And what this image PNG is, it's actually an image file which contains not just sprite1, but it has all the sprites in this kind of like grid, in this map, as it were. So what we have here, let's say something like sprite1, sprite2, where am I? Sprite3, sprite4, all in our sprite sheet. And it's an image.png file. So sorry for taking the time to explain all this. I just think it would be a nice little primer to help give a little bit of context of what I'm doing. This is just kind of a chill stream, really. So what we do then is, okay, we have our sprite sheet. You're probably already guessing where this is going. What we're going to do is have a functionality in our program that says, okay, going to take our sprite sheet object here, which we pass as a bitmap object. So we have our bitmap object. But what we're going to do, we're going to pass our bitmap object through a function like a crop function. So we're going to crop our bitmap. We're going to call a crop function, pass the bitmap object in the overload. We're going to also specify our dimensions, so our x, y, height, width values that we want of our crop region. Yeah, our x, y, height, width values of our crop region. And what this function will return is the cropped bitmap object. And then so what we can do is crop the first. We can actually create like a loop that will crop the regions of sprite 1 in the sprite sheet, sprite 2, so on and so forth. And then we're going to have basically, we are passing one sprite sheet, one image file, but we're getting multiple files. So it's almost like not multiple images. It's almost like a form of compression. And it just saves a lot on resources, especially when you have a lot of sprites on that you need to load, But for the sake of speed, more or less, we're going to go by the frame-by-frame approach where we load each frame individually. I do have some very rudimentary assets prepared for this. So if you imagine the Chu-Chu-Rocket, these are like the mice, right? I have very, very basic sprites like these kind of mice, as it were, going right, left, up, and down. And I have a basic background grid just so we can see what is going on. All right, so now that that's been explained, that was quite the detour. Just gonna put this here. Just go to the top of my notes so you can see what's going on. So what I just explained is basically, in terms of the frame-by-frame approach, is basically what I'm doing here. So I'm loading the bitmap from file path. As you can see, the logic is all here. I already wrote it out. Accessing my file path here, assets background, and the file is GG. Just to save on a little trick I've done here. If I keep naming fairly generic, what that just means is I can have a loop. If all my files in a certain set start with GG, then I can just prefix them with an index and then use a loop to actually concatenate the file path. So that I don't have to always hard code here one line, gameplay grid 1, gameplay grid 2, gameplay grid 3, so on and so forth. I can have one line of code that loops and just uses an index, basically. So it's good to just kind of keep that generic standard of how I'm naming my files, generally speaking. And then eventually I load the bitmap assets for accessing the render flow, namely the draw calls. So I loop through the outer list, and I loop through the nested list. Then I load the bitmap graphic from image file, and I just basically store the graphic in a nested list. So what we're going to do, I'm going to put a breakpoint there. I'm going to just kind of run this by debugging. Let's check the chat, see if there is anything I need to be aware of there. Make sure I'm still there. Yep, everything looks fine. Sorry for breaking the flow, guys. So this is just loading up now. Hopefully my computer won't be too slow. I'm not running the best machine, but it does get me by. So I'm quite happy that I've got this desktop. Just gonna kind of move that out of the way. Maybe just minimize this as well. Make some space. So right now my program is just loading. It's gonna come up any sec, I think. Yep, thought so. Using UWP here because it's what I quite like. It's well compatible with the Win2D library. Win2D is what we're going to use for today as the front end framework, more or less within the scope of .NET. Do excuse me. So we'll just wait for this to load. Here we go. So we've hit our break. So we've executed all of this logic here. And what I'm going to do, I'm going to go to my watch list. I'm really hoping that you guys can see, because it's a bit tricky to zoom in here on this part of the UI. I've already put on my local, in my watch list, the sprite local file path object, which is, let's see if I can find it, up here somewhere. It's actually just a property of list of string, which returns a private field, which is of the same type, list of string. It's a private field, which is basically, it's just like a layer of protection. I'm accessing via public property. So where am I? Go back to the logic. So over here, if we kind of want to expose what happened on line 154 here, which is quite important when we're actually constructing our canvas bitmap object, adding it to the list on line 158, I'm going to go to my watch. I'm going to go to the sprite local path list. We have the list here, as you can see, hopefully. Have the list. Index at 0 is one element, and we should have another list, which is my file path. And it's really hard to see. I know, I do appreciate that. But if you are able to see on the screen, it is my file path and GG_0. So that GG_0, which stands for gameplay grid, as I named, is this GG_0 asset right here. So we have successfully loaded a PNG file, which is actually quite large, 1080 by 720, but it's only like 430 kilobytes, so not worst. Anyway, we've loaded GG_0, our asset, and converted it into a bitmap graphic, or a bitmap object, basically, and stored it in some kind of structure. And then if I just go ahead and continue, I think my computer just seem to be hanging now. See if I can just continue if there's no errors. Hopefully there's errors. Excellent. So we have our XAML here. Now I haven't passed any render logic, as you can maybe have guessed, because my I haven't gone through that. So we're going to go ahead and start that. It's just some of the XAML controls I was talking about, just kind of experimenting with the layout of, like, say, a scroll viewer, some card UIs that don't really do anything, some arbitrary controls. But what I want to do, focus your attention on, is this middle bit. There's the canvas animated control. Really hard to see, it's just like a white screen. But we're going to hopefully be able to render some imagery to this, so it should be quite fun. So while we're here on my agenda for today, build a simple render pass system. So we're still working on this one. I wouldn't cross it out just yet. So we've already touched on this. Load resource loads all the bitmap assets. So I will cross out this kind of sub milestone. What else did I write? Updating placeholder sprites and general components should be smooth. So that's like just pointing to my folder structure. Let's go and try and render these graphics. Let me take this out. So where can we start? Let's just have a look at my flow here, so I know I can get my bearings. So what we ultimately want to do, and just something quite important to note, is that I have had this situation where the draw core tries to execute off before the resources have loaded, which is quite an issue. I think there is a system in place for that to not happen intrinsically in the library, but I have had issues where my program crashes because of this. And what I do is very simple. It's very simple. It's just common sense, really. I don't core draw until after this is constructed, right? But I had this situation whereby there was a bit of a clash. It's a bit. If you go through the documentation of the Win2D UWP library, you'll see what I'm talking about. Sometimes you're trying to draw resources that haven't been loaded, so it's something to note for your render flow. But anyway, for the draw core, we hooked it to this function in our model folder. So if I go here to the Solution Explorer, I have a folder here called Model, and I have a draw class. And in that draw class, as you can see here, is this animated draw function. Let's go ahead and see what's there. And of course it's empty because we haven't done anything yet. Now I'm going to be referring to this, in case you were curious, this Notepad++ file is actually from if you see my previous video, from the Parallax engine, which is my proof of concept 2D game framework. I really want to make some more entries in the series got the Parallax engine. What I'm going to do most likely is just kind of, if not refactor, just remake the engine from scratch, because its folder structure is, I would say, quite pitiful. It's quite pitiful. I need to make sure it's structured well, because I was kind of figuring things out. So like objects are everywhere and stuff. So in that respect, I'm still going to kind of lend my attention to this file, the main page, and all the C# in the Parallax engine stuff, because I did write a lot of functionality I can kind of borrow from. So for example, excuse me, if I quickly go to the animated draw in my notes, if you can hopefully see, I'll see if I can zoom in here. And this is how I like to save time. I write functionality one day for a different project, I see the need, and I literally just use the functionality another day. It's just super simple stuff. So what am I going to do? I'm not even sure what that is. I can't see the whole thing. Yeah, that's about right. So in this class draw, I want to kind of put generally all the draw logic, and then I want to parse it back to the main window where the animated canvas is, because it's tied to the XAML. So we have to kind of handle that stuff in the XAML level, and then we're going to hopefully render to the screen. So what we're doing here, there's a argument in our overload. It is the canvas animated draw event args, which we're accessing via a variable called E. And E has a member called drawing session, and drawing session has a member called fill rectangle. Now, we're not going to be using fill rectangle, I just realized. So I'm going to get that out of the way. Let's have a look what's here. It's a bit hard to see. There should be a draw here somewhere. So we're going to go to draw image. Now, if I'm not mistaken, there's a ton of overloads for this function. There's 19 overloads. What we want to do is keep things as simple as possible. We're not going to pass a iCanvas per se, but what I want to do is pass a canvas map and a rect. And what that basically does, sticking on my feet here, if we say, thinking what the best way to do this is, okay, let's lay the foundation first, and then we can look back and see how to improve it. If I say have a private, and I think I might need a namespace. No, I got the struct. That's so cool. The namespace just come into add itself on my Visual Studio. That's really cool. I've never seen that before. That was anyway. It maybe did, maybe didn't. I don't know. I think it did though. Private rect, and let's just call this bounds rect bounds 1. Let me not mix that. Rect bounds 1. I like to use lowercase for my fields, generally speaking. And I'll declare it there on the constructor, this rect bounds. And again, we're going to just lay the foundation here and then sort of improve as we're going along to see how we optimize the functionality, the code, and the structure, and so forth. How am I doing for time? Just check my OBS. How am I doing for time? I don't see. Okay, it's about half an hour. That's fine. What are we passing here? Oh yeah, we're making rect. So I've constructed this rect, but actually what I want to do, not the field, I want to construct a property. So I'll go ahead and say public rect, rect bounds. I'll give it the same name convention so that we can identify that it relates to this private field. I'll go ahead and make my property body, give it a return value. Oops. Oh, sorry, I did that wrong. So I'll give it a get. And I'll put a set as well. And now I'll put the return value. So I'll return the respective field. And then the field value, field is assigned value, keyword. So we set up our public properties. So we have access to this rect class. And we've constructed it. So what we have to do is pass a rect into this overload. And the rect is essentially going to be the bounds for which our image is going to be drawn on. The canvas bitmap is going to be, if I'm not mistaken, a sender argument here from iCanvas animate control. And let's see, let's give the rect some bounds. Again, this is just, let me see how I can do this. Okay, so what I'll do, I'll say private, let's make things fairly modular. Private void, let's make it public actually, just in case. Although I can access it from this member probably through the constructor, I'm not too sure. I could do that. Public void, and let's just say generate rects. And in this functionality, I will basically give my rect bounds some dimensions. So we can say height, let's just say 200, maybe like 300. Oh, I mean, I don't know why I said that. 200 is fine. Oh, what's the issue here? Can I modify the return value of... Oh, that's strange. Quickly check something. Oh, that's not right. Okay, sweet. I'm sure you could do that. Just quickly check my notes, because I'm sure you have to give the rect. Ah, yeah, I remember now. So what we need to do actually... So because we're dealing with the struct, what I'll do, in the constructor, I will call my generate rects. And when I have to construct this rect, through the overload of my constructor, I can set the parameters for the dimensions. So as you can see here, overload 4, I've got x, y, width, and height. So x value, let's just say 0, 0. We're setting our rect image in local space, in this local space. Width, let's just say 200, height 200. So generate rects is constructing a rect and it's giving it some dimensions. and that's going to be called once this draw function, this draw class is constructed. I'm doing that right, and then that means we can hopefully pass our rect in here. Now this is the thing. Oops, see, this is right. Can I convert case? Actually, I'll quickly look at my notes just so I can keep it consistent. I'll use the same overload draw. How did I go about this? I'm gonna try and find draw image. So I was doing a transform effect approach here, but I'm not gonna be using transform effect. This is a different way of doing things. I'll take this and we'll see what's going on, just so I can have a fair idea. So it's to access our canvas bitmap object and then the rect. Not sure why this one. 1 second. Just streaming. So I'll get back to you in a sec. Yeah. So anyway, sorry about that, guys. So anyway, what am I saying? Where am I? So it seems I did something wrong. Windows Foundation rect to vector 2. It's expecting a different overload. So let's see if we can't pass our canvas bitmap list through a reference, and then we also pass the rect. Okay, that shouldn't be too difficult. So if you remember, where am I? I have load animated resources, which has our bitmap graphic via our list of list. If you remember, which I'm sure you all do, right here. We need to access this. So if I go to my directory, we need to access canvas bitmap list, which is in the load animated resource, which I think is in the view right here. We need to pass this to our model, which is the draw functionality. Now, I am thinking of utilizing the controllers, but I don't think that's necessary. Rather, because it's so good to just keep things simple. And besides, controller is more like controller, if I'm not mistaken, it's more of like a user input pipeline and what you do with the user input. So when I say pipeline, I mean I'm taking the user input from the source and kind of parsing it, and then using business logic to kind of see how to evaluate what you're doing. So I wouldn't use the controller, do anything there. No, what I would just do this way, I can expose using the public property. I'm going to make it as simple as possible. This is the public property, so it should be accessible from the main, but I think it should be accessible everywhere throughout the scope of the solution, if I'm not mistaken. I'm going to check, but then it is in a folder, so I might have to pass it to the main. So let's have a look. This is probably out of scope, so I'll just excuse me, check. Of course, that's out of scope. So what we'll do, when we construct this, we're going to say, okay, we need a list. We need our canvas bitmap list. So we're going to ask for a list. Of canvas bitmap. We're going to call it, how about we call it sprite sheet? And this is just a very rudimentary approach. And this sprite sheet, we're going to store it in global scope. So then I'll have here private canvas bitmap. No, sorry, private list. Canvas bitmap. Sprite sheet. Okay. Before we call generate recs, what we're going to do, we're going to say this sprite sheet is assign the past canvas bitmap sprite sheet. Just change that quickly. So with control draw, we're basically asking, okay, I'm going to construct this class, but I need this parameter, this list, which actually should be a list of list. Keep things consistent, I guess. So I'll make this a list of list. Okay. And then we call generate recs. So what we can pass, therefore, if I'm not mistaken. Now here's the thing. Again, we'll send the framework. We're gonna take a step back, hopefully, eventually, and I'm gonna look. Okay, this is what I'm rendering. How can I improve the logic? So what I'm doing here, I'm saying render a simple scene. I'm gonna say draw the background graphic, stuff like this. And we're gonna see if this works. So I'm gonna pass this. What's it called? Canvas bitmap this? Or sprite sheet? That was it. Sprite sheet. Funny thing is, I shouldn't really be hard coding values. I'm not sure if this is the case. Yeah, because it's a list of lists, so I have to access the nested list within the outer list. Hence why it's 2 indexes here. So list inside the list. So I got nested list. So that's why I have to do it like that. So I got that, and yeah, the error is eliminated. So let's just get rid of this. Let's using that for reference. So if I'm not mistaken, we are saying, okay, program, I want to, in my list here, which is a list of lists, which is passing a canvas bitmap object, we want to render the canvas bitmap object via this function and place it in this bound, which we've constructed here. Where's construction? Oh yes, generate recs. So let's see if this is actually going to work. Let me make sure I've got the flow right here. So where are we constructing draw? I need to go ahead and see this. Now, obviously, there's an error because it's expecting an overload, an argument there, which is our list of lists. So since it's a public member, we can just simply say, do I have an instantiation? Okay, in this case, because we're at field level, don't know if this actually makes a difference. I'm going to actually instantiate this at constructor level. And you know what might make sense? I will instantiate it after the resources are loaded, just to really help ensure that I'm not having clashing. So I can say this, and what was the name of the member there? Draw is, and I think I copied it on my clipboard. I don't know what's going on. Equals new model draw. Our list of lists which we have access to via our, I think it's our view member, which is load animated resources, and I made it public, I think. So canvas bitmap list. Okay, guys, gonna take a short break. We'll be right back, okay? Let's just make sure that's all right. We'll be right back, guys. Check that OBS quick. And we are back. Sorry about that, guys. Thanks for waiting. Let's straight back to the stream. Let's check my dashboard, make sure everything is sound. Hopefully the stream's still connected. It should be. When I see that loading, it's just like telling me, I don't know. Let's just make sure the stream is connected. Yeah, I'm still online. Excellent. Sweet. Okay, so just to make sure there. Okay, guys, we're kind of reaching that 1 hour milestone. Let's see how much I can do. Let's at least get something rendered to the screen. Maybe I'll even cut this down to hour and a bit. We'll continue later today. Maybe I'll split into 2, or we just continue. We go with the flow. Let's see how much we can get done. I'm kind of liking the flow here. Where am I? Let's just go back. So I just established a bit of a flow for. Oh yeah, that was it. I had to pass into the constructor the canvas bitmap object, right? I've completely lost my trail of thought. Load animated resources. Constructor. Yeah. So draw. Yeah, that was it. So we're passing into the draw the canvas bitmap list, which we've already populated via our create resources event, which is calling a function which I showed you earlier, the create generate resources function. So what should happen here? Once we construct draw, we already have access. If I go to my solution explorer, we have access to our view from our models folder, because here we're in draw. We have access to our view, we have access to load animated resources, and we create a reference to our canvas bitmap list of list. And then what are we doing? Where am I? Make sure I'm in the right place. Draw. Then I am basically making a global reference to our list of list, canvas bitmap. Calling this function generate rects, I construct a rect. And then we have the animated draw. I'm just worried that this animated draw might draw before the rect is generated. So what I'll do... Oh, is that correct? Anyway, leave that. Okay, that's not awaitable, I guess. I'm guessing. Yeah, it's not awaitable. So what I'll do for now, I guess... Because what happened if this calls by any chance before the resources are passed, it will just, because it's a draw call, it will just keep looping until the resources are available. So I just have try catch like so. So if in the case our rect bounds, this calls before the rect bounds is generated by any chance, it will catch the exception. It will keep going until the rect bounds is constructed, and then we'll have this should execute. Let's have a look at this. Now this is interesting. I'm just trying to see what I'm passing. Now because I'm passing the e.drawing session, I have access to the canvas animated control here via this argument and the canvas animated draw event args. So I think we should, as long as ultimately with Win2D, when you call this function draw image from the drawing session, that's literally all you need to draw something to the screen, be it a rectangle, geometry, as they have functionality here. If I can just show you, hopefully it'll be viewable. There's a few draw options. We've got draw circle, draw ellipse, draw geometry, so on and so forth. We're using draw image. So I think if I run this, hopefully we might get an image, or we might not. We might not if I've done something wrong, but I'm going to just run this and see what happens. Let's see. Don't get an exception. Very likely we'll get an exception somewhere. Maybe I have to just tweak something. But I'm more hoping we just get an image. So let's have a look. We'll see what happens. And then once we get past this, well, we actually, that's my notes. Then we would have essentially set up the flow, render pass flow, and then so I can cross this out. Because what would be next to craft our scene, we can use the structure of our render flow, and then the next thing I think is about controller parsing. Yeah, the input system. So let's just see what happens. I'm hoping it works. Unless I missed something out. Sweetness, I'm happy to see that. So if you can see there, we have our gameplay grid. Nervous laugh moment. Anyway, here we go. Gameplay grid is right there. It's a little bit hard to see, but that's in our canvas bitmap, which is in the middle, placed in a kind of a square in the middle of the screen. And obviously this is 200 by 200, so it's pretty small. We can always adjust that. Quite happy to see that we have liftoff. How are we doing for time? Actually, no, I'm not going to look yet because there's a little bit more I want to do. Let's make this grid fill a portion of the screen, so it's a bit easier to convey what we're trying to do here. So firstly, I'll actually cross that out. So we have successfully established some kind of render path system to draw graphics using our CSharp, Visual Studio, and Win2D. Let me make that capital X. I can be a little bit picky like that. Let's go back to the draw. I'm gonna change this. I'm gonna the dimensions of the animated canvas. I wonder. Let's see if I actually set it anywhere. It's like It's like 1600 by 1500. Let's roll with that. 16 by 15. Go to draw. I know there's a limit of how large you can make your I think canvas bitmap images. Like 16,000. I can't remember exactly. What was it? It was probably a bit more, I think. Let's round it down to. Ooh, that's a large number there. 1,600. I think it was 1,500. Kind of a. I was gonna say boxy look. It's more like a lateral. The lateral dimension is prioritized to be a bit longer here. I think it was width height, if I'm mistaken. I'm not sure. Can't remember. So once we get that, I'll just do a bit of tweaking. I wanna work on the input system next after this, because if I can get the input parsing to work, then I can start adding other assets on the screen that could interact via the input parsing, so that I can kind of create basic player movement. I think I'm about on the hour mark. I want to kind of round this up. Oh, that looks so much better. Isn't that nice? Just a nice graphic there right in the middle of the screen. Now here's the thing about Win2D. It's if you have worked with lower level graphics APIs like DirectX, you'll know that obviously when it comes to window sizing and things, it's something that is a little bit involved. You don't have the liberty, you don't have the free. What's the one I'm looking for? You don't have the luxury of like XAML fluent controls. But if you look, the XAML control. Okay, I'm gonna stop talking. Because I didn't know that would work. So this is interesting. I can actually resize the component and it somewhat is responsive. Everything I was about to say, guys. I didn't know I could do this. I thought it would just clip. It does kind of clip, I think. No. Okay, I'm gonna just stop talking. Okay, really, that's welcome. So we have decent, I would say fairly reasonable resizing just right off the gate. Obviously, probably be configured manually if you really want to, but no, I'm quite happy with that. So let's move on to the next stage. So as you can see, I kind of want like a little bit of a HUD here. Maybe have like a high score on the left and maybe some options like special items. Remember, I'm trying to do this Chu-Chu-Rocket idea, whereby you're controlling units on the square. Basically, that's all it is. You're controlling mouse. They're actually mice. So I'm not going to do mice in this case because obviously this is a completely different. It's just a idea, really. Player units on the screen. It's just kind of puzzling that aspect. I like that. Let's go to the input parsing. I've already kind of covered this space because for the structure is like MVC basically in terms of the concept. Let's turn our attention to the input parsing logic. So what I've gone ahead and done in the main, I have this main VB key down. Yeah, let's put a break there. So every time I press a key down on my control called main VB, which is actually stands for the main VBox control, which is a XAML control containing the animated canvas control, I think, if I'm not mistaken. I'm going to execute a logic, basically, and that logic is going to be the responsibility of the control logic is going to be in our controller controller folder, which is going to have our input parser, which I already made ahead of time. Just go ahead and save my work. So what I got here, let me put this here so far. All I'm doing is I'm constructing a key down, which is a virtual key object. Excuse me. Virtual key class, which I am constructing here as this key down object. And what we really want to say is, let me see, I'll go back to my notes. So we're done with that node, with these nodes here, with the frame. We're going to say stuff like, let's see how I can do this. If key, say, and let's say the majority of PC gamers are familiar with the WASD or WASD setup. Let's say if you click W, if key.w is true, let's just say it like that, key.w, then let's just say move up. It's literally just an idea, right? So we want to basically say if we press a key, we want to execute some kind of logic. That's what we're going to do in the input parser. And then this, yeah, and then we're going to build on that. So let's go from there. I don't want to jump too ahead of myself and confuse myself. Where am I? We got the key down. You know what's interesting? Let me see where I am. I'm thinking of using enums. I've already set up enums. It's somewhere in my notes. I sometimes forget how to set up enums, but it's not that difficult. Let's have a quick look here. Where is that enum that I created earlier? Let's kind of just take from this. Just to save time, isn't it? If you've already written code in your own framework and you need that functionality, why not just take it? That's what I believe. That's my philosophy. Sweet. So I have here an enum, public enum called player state. So imagine the state of the player. Do excuse me. But since we're controlling various units on the screen, again, refer to the game Chu-Chu-Rocket to see what we're talking about. We're not really controlling the units as well directly as we're controlling an arrow telling them where to go on the screen. So instead of player state, I'm going to change the name. I'm going to say like, actually, you know what? No, I'm going to leave it like that. Just let's not complicate this. But we're only going to need, for now, like 4 items. Left, right, up, and down. So let's say left. We can either be pointing to the left state. We could be kind of going to the right state. Up and down. Let's just say for the sake of argument. Okay, so what we want to do is have a function. Where is this? Where is input parser? I think it's in the model, right? No, controllers. What I'm considering is calling input parser from our update loop in our model. I think that might not be a bad shout, because the business logic of update pertains. We don't want to have another loop. We don't want to construct our own input, our own like control parse loop using, say, like a dispatcher time, which is not a bad idea. But because we already have a draw call and an update call, why not use those? So what I'll do in this front, on the input parser, I'll create a function, and I'll make it public because we're going to access it outside of its scope. Public void, and let's say parse key input. Oops. How can we go about this? It's very simple, just like my pseudocode suggests. Very simple stuff. Oops, my computer just froze for a second, it seemed. Check my OBS, make sure everything's there. Yeah, I'm fine, okay. So if, let's say, oh yes, so, let me just have a look, get my bearings. Bearings. Okay, person. Where's the key down properly? Yeah. So if this key down is basically let's say I'll use W for now. So it's like what key? I forgot the name of the. I forgot the names. The name. It's right here, I think. Windows System Virtual Key. Virtual key, and we're going to look for W, which should be towards the bottom. I think it's in alphabetical order. There it is. So if we press the W key, essentially, we want to, let's just say for the sake of argument right now, we want to go up. Simple as that. Let's just put a break here. So we can just evaluate we can just kind of observe what's going on by debugging. Now we're going to call this in our, as I said, the models class. Again, I'm not adhering to one-to-one MVC here, but it's just for my own reference. I'm still even learning MVC at the moment. Very fascinating stuff. It's somewhat of a rabbit hole going down like patterns and stuff, but it's a rabbit hole worth exploring, I would say. So if I go to my update, which I haven't really done anything in here yet. Let's say in our update loop, we want to evaluate user inputs. So evaluate any user inputs. So here we're going to be checking via our function if there's any user input. So in a similar way, we accessed, let's see, how am I doing this? Look at this. Now, we don't want a situation where we are struggling with instancing and having like different instances of different classes and objects and thus missing references. So what I'm going to do, I'm going to pass a main page. Again, there's probably optimal ways of doing this. This may be the best way. Pass main page. Let's say main page reference. So I'm going to store a reference to the main page. I'm going to give it a value. So I'm going to assign main page reference as main page. Oops. And then I can basically say main page reference. I think it was controllers. Do I have access? Okay, not to worry. Let's just see what I'm doing here. So we'll go to the reference. And again, because we're passing an object, we can't instantiate this update at field level. So again, I'll go here and I'll just simply say this update. And that's constructed here. But this time we have to pass reference to our main class, this main page. So I'm going to just call this keyword. Where were we? Was it input parser? Yeah, no. It was a different class. It was the view. I've already forgotten. It was update. Now I don't know if I can access like this what I need. Can I access members? I can. Let me just have a quick look. Where is it gone? What do we need? Just gonna change the protection level. I'm just thinking if I really want to make this public. Again, let's just get this. Let's get the car rolling, and then we can. Yeah, I thought so. Okay. Okay. So I'm already forgetting what's what. We're gonna just play with the protection levels quickly. So essentially, we want to access controllers. I'm gonna go to the input parser class. I'm gonna make it a public class. See what happens. Controllers. I'm gonna make this public. Input parser. Oh, okay, I haven't constructed this yet. And so we want to say this update this. Let's actually construct this. I don't even know what I'm doing. I've already got confused. Let's see. Okay, this is what we're working on. So when we construct this, is the constructor doing anything? Okay, nothing too important. So let me just leave it as it is for now. Because we're not using this yet. We're working on it. This is not difficult, I think, as long as it works as I expect. It's just that I've actually just literally lost my trail of thought. Controller, draw, update. Yeah, that's right. Passing this. So if I go to update. I don't know. Can I access the member? Oh, something's come up that's different, I think. Input parser. Here we go. So I just have to think that I was a little bit sluggish in my mind, a little lethargic. So we have access to input parser. Evaluate any inputs, user input. So we're gonna go into this class, and we have access to key down. And remember, if I go to where this key down is scoped, key down is a public property, which every time we change, we say in this case we click W here. Yes, if we click, if we say right W, firstly we want to change the state of key down. So we're gonna say this key down is equal to virtual key W. That's the first thing we're gonna do. Go up. So again, this is just really quick logic to get the ball rolling. Go up on the screen, which means that pass the W key to global scope. And now that that's in the scope that our controllers namespace can see, if we go to, let me just quickly go to my solution explorer, not the input parser, sorry, the draw core and the models. Oh, sorry, it was the update, not draw core. Then we have access to this, so we can now evaluate this. We can say if the key being pressed on the main page is W, then we can say go up, basically. Very simple. I had a breakpoint here somewhere. It was in a different class. So we can execute some logic pertaining to going up. And so just as I was, so yeah, I'm not really done here yet. So what we can do, let me just get rid of some of these tabs that kind of confuse me. I'm not looking at the server stuff anymore, not the packet stuff. Let's close that. All right, sweet. Let me get rid of that. So this is the animated update loop. And if we go to the Solution Explorer, go back to Controller, go up past Global Scope, and then the loop picks up on this change. And essentially what that translates to is basically our character being drawn going up, right? So we can do that in a variety of ways. And what that's going to translate to is the rect bounds being translated by modifying It's not even modifying its dimensions and position. We're gonna construct. We have to construct a new rect because what happens if I'm not mistaken? I might be wrong actually. With rects, if I try to access the X and say give it a value of 20. There's this error, cannot modify the return value. You have to actually construct a new rect and give it a new value. Just put that back. Yeah, that's fine. Let's just make sure I've got this. If key move up. Where did I put the state enum? I've already forgotten. It would be in the controllers, I think. Yeah, sorry guys, I'm just really slow right now. So I think I can construct this enum because what we want to do, we really want to work at a high level. We want to sort of create a system, at least in my opinion, whereby we have high level components that we can build and we can essentially program, and that deals with all the lower level details, all the lower level modules. We don't really want to be building a framework for our game that when we want to make a change, we have to go into a lower level per se, because it could be a whole rabbit hole the more complex the system goes. Rather, let's create high level modules that interact with the lower level modules. That's why I'm opting to use this enum for player state, because we can just simply say, okay, left, right, up, and down. Right. So that's kind of a high level idea of what we want to do in the program. So at constructor level, I think I can construct a new enum. Let's just say player state, and let's just say state. Just keep it simple. Equals new player state. But no, that's right. Yeah, I use enums too much, so I wasn't too sure. So what we can say, not only do we go up, does the key down go up, we could even change the state. We could say state is equal to, oh, what's wrong here? Oh, whoops. Let me put that in global scope. I don't know if that's going to work. Yeah, it's fine. So what we're essentially doing, player state is up. As you can see, I have access down, up, left, and right. So we could even evaluate via player state, or we can directly evaluate via key down. It's up to the direction of the program. So what I'm going to do, so we can just kind of, because I'm already kind of losing my trail of thought, I'm going to put a break here. So that once we hopefully hit the key down, we have the event trip, and then we can kind of see what's going on from there. Hopefully I don't have any breaks in the draw call, because that would just kind of slow things down, but that should be fine. Oh my goodness, what are we doing for time? About 1 hour 20, gonna see what I can do here. This is definitely gonna be a set of streams, rather than like a whole block. You know, it's just a little bit more efficient to go through things and know what you're doing. So my UWP session is loading. Excuse me. So in that main view box, I'm gonna let's wait for it to load. Hopefully the graphic comes up. Okay, so object reference not set to an instance of an object. I just have to construct input parser, I guess. You know what? I'm gonna put a cache there quickly, just to get on the safe side. Just in case, so just avoid crashing. I'm gonna make sure I believe. Oh yeah, the input parser wasn't constructed. I just remembered. I remember now actually. I'm gonna just close this. I wasn't using this variable. So for now, let's just construct it at the top. So I don't think we're passing anything yet. I'm gonna hop straight back in. Let's see what's going on. excuse me. And let's see where are we. So if the flow for the input parsing works, then we would have built the simple, if I'm not mistaken, the simple input system, and I can cross it out, cross off our little milestone list there. So as you can see, my approach here is to just kind of set the framework, the bare fundamentals and the foundation, and then build the game, build the level, build the system, build the level, build the game, and of course you have your title. Goodness. Wait. So I'm gonna just click this. I'm gonna hit W. Sweetness. Yes. So we have our key down, but we don't have the logic in there. So what I'm gonna do is I'm going to call. What was it again? Is it input parser? Oh yes, of course. So we're gonna call this. Let me just stop this program for a sec. So what we're gonna do, another extra step which I may have overlooked. Hopefully I'm doing this right. Gonna take as an overload the virtual key, and we're gonna say pressed key, and we're going to just say this key down equals this, and then we can evaluate this accurately. Okay, let's go. Didn't call the function. Where am I? So I need to go call input parser and then my functionality. Just wait for the stop button to come up. Or I'll just wait for the... I'll just add it after the break, I guess, if it was to run. And then let's see. This definitely we won't be able to go through tooling today. That's a whole section in itself. Let's have a quick look. So for my program to load fully, I'm just gonna click W. I'm gonna call input parser and the general. Is it here? Pass key input. I think that's the function I need. Just double check it. Check it. Oh yeah, of course it's overload. The overload would be E, I think, the argument from the event. Let's actually not get rid of that. Let's step through. Okay, no. Let's stop and reload. Obviously, visualstudio didn't like that. In fact, there's an error. Okay, so we're gonna go to the. I should have just done this. So key, and that's it. I think that's passed successfully. There's no errors there, from what I can tell. Let's go ahead and debug. See what happens. I'm gonna wrap this up. I do appreciate it's Christmas Day. You know, do a little bit of a stream, just at home, chilling. It's nice. It's all good. So I'm not gonna make this too long. Okie dokie, that's loaded up. Just wait for the rest of the program to load and render the image, and then we'll just proceed. So I'm going to hit W. So then we're calling our parse key input function, our input parser. The key down here, if I just evaluate it, key down is none. That's very fascinating. Oh, of course, because I haven't assigned. Sorry about that, guys. So key down, hopefully you can see it says W there. So if key down, which is W, is equal to W, so that should go through. Then key down is this is redundant. We don't need to assign W if it's already assigned. But what we're interested in is the state. So this state is up. So guys, just by this, we know we have a flow set out. We have a flow whereby our input parser is saying the state of the player. I've gone ahead and it's left by default, but it's gonna get assigned to up. So if I hover, it says up now. So technically we're moving up, as it were, in the game. And obviously the game continues to render with the underlying logic running there in the back end. I'm gonna go ahead and cross that out. Going to cross our milestone. So build a simple input system. Let's do that there. And yeah, that's kind of what I want to go through today. And we're gonna build upon this now. Because obviously building a game in like an hour from scratch is not something that's like you need a lot of time. And I just go through the bare fundamentals. I really sped run this. I was really pacing myself through this. We're gonna take it step by step. So in the next episode, what I want to do, because I did kind of say I will look at the sockets thing today. I did kind of go through it. Don't want to really deviate too much, so I won't demonstrate the packet stuff. But what I will do, hopefully for the next stream, is I will get the packet stuff running so I can demo it at the start. And then we kind of, even though we're kind of a ways off from the networking functionality, we have to kind of build the game first. I'll just demonstrate that in the next stream, hopefully. So, and then I will see off screen, I will see if it's necessary to make very simple debug tooling, just like monitoring like player positions and stuff, and like general dimensions of my rects and whatever. That will come under this milestone. And just make sure I'm not missing anything. Let me check my time. Just about 1 hour and a half. I'll quickly check my dashboard. If it's gonna load quickly, I don't know. Guys, thank you so much for tuning in. I really do appreciate this. My name is Will. Check out the description for more information. And I bid you all a happy Christmas. Thanks so much, guys. Take care. Bye-bye. Okay? Let me see. We have a question. Between game developer and web developer, which path is harder? I'm currently in. Okay, so I'm not really. I'm not the most qualified to answer this. It really depends. Between a game developer and a web developer, which is harder? I would say, in my opinion, I mean, firstly, you gotta consider the stacks. So if you want to say do a game development, for example, you might be learning DirectX APIs. DirectX is a low-level graphics API, which is basically implemented primarily in C++. It's pretty, should I say, it's pretty intense, and it demands experience and it demands knowledge of the API if you want to use it to any kind of, industry standard level. If you want to go the path, if you ask me, this is what I believe. If you want the most lucrative and the industry that I believe has potential, as I said in the beginning of the video, I believe the web is next. 1 second. Hello? Yeah, I'll bring it out in 5 minutes. I'm gonna cut the stream in a sec. Just can you wait like 5 minutes? Literally. Thanks. Sorry about that, guys. So basically, I believe the web is next. So if you learn and you're competent in a web stack, then literally there are so many jobs going for the web right now. There's so many jobs where they want you to learn web stack so that you can build the future of technology. But if you have a passion for gaming, if you have a passion for video gaming, by all means, you can explore like I do. You can explore DirectX APIs, you can explore Unity, see what floats your boat. I believe there's more potential, generally speaking, in the web side of things, because you can implement web technologies in game dev, but you can't necessarily implement game dev in web technologies. And game development is such a niche sector. If you want to kind of have a scope for what you want your overarching horizon to be, I would say learning web development, you cannot go wrong. You just can't. There's too many jobs for that. But for games, a little bit more niche, but it really depends on you. So I'm not going to tell you what to do, but I hope that little bit of insight helps. And all the best with your college. I'm sure you'll do great. Keep it up. All right, guys, I'm going to end the stream now. Thanks for tuning in, guys, and I bid you all a great day. Thanks so much. Bye.